I want to remind you of a few things. You know, the slope is the change in y over the change in x. So if, like for this one, if we go up to and over 3, then we would say that the slope is 2/3. All right, change up to and change in x is 3. And the same would be if we went up 4, 1, 2, 3, 4, and over 6, 1, 2, 3, 4, 5, 6, we get that same ratio. So it's the same thing as 4 over 6, rise over run, and the same thing if we go even further, this would be 6 over 9. Well, an easy way of representing this would be to just write, okay, well, change in y over change in x, let's just go over 1 unit, and then that's our slope. So that's one way that we could represent a nice little triangle, just in general, that if we have 1 here, this will be my slope if this is my line. All right, so that's one thing to kind of remember for the future. The other thing to remember is that the derivative gives you the slope at a particular point. So if this is f prime at my number, let's call it f prime of 2, and we go up to and over 3, then that slope would be 2/3. So the derivative gives us the slope at a point. Now, one other idea then is this is the curvature. That is, how fast does it change? And so roughly for our purposes, the curvature will be f double prime of a. That is the second derivative of a, and that will tell us how much the curve is changing. So for example, at this point here, that point right there is f of 0. The slope right there is f prime of 0. And then the second derivative that gives us the curvature will be the second derivative at 0. And what happens is that if f double prime of a number is small, then it's relatively, and let's make it also positive. That relatively makes it slowly changing up. But if f double prime of a is large and positive, then it increases quite steeply. All right, so we're going to be looking and judging some values like along this line, and we want to be able to look at the second derivative and the coefficient of the second derivative. So that's just a brief review.